we have completed till the heat capacity. Just please go with the notes. Just revise the notes. And if you have any doubt, just let me know. So today we are going to start with the measurement of heat. Okay, so in which we will do some calorimetry here. So we will see the basically the principle, how it works, and what is the use of the bomb calorimeter and the coffee cup calorimeter. Two types of calorimeter are there. Okay, so let's wait for others. Like Aisha and Zainab has not joined yet, so let's wait for them. Then we will start the session. Okay. Okay, so I don't think they will join the session because Zainab का आज exam था and Aisha and yeah, this chapter is not coming in Aisha's exam, so I think they will not join. Okay, so let's start the session. So measurement of heat. So we will learn that how we can measure the heat. Okay, so there is a method which is known as calorimetry. You will perform in your lab also this calorimetry. Now, so what does this calorimetry means? Calorimetry means. So it always in science always try to understand the meaning of the word, okay, by breaking the word. Like this calorimetry. It so basically calorimetry किससे बना है? Calorie plus meter. Okay, calorie plus meter. So it's calorie plus metry or meter, you can say. And what does calorie means? So calorie is the unit of energy, means heat energy. Because we are just talking about the thermodynamics. The thermodynamics में हम किसके बारे में पढ़ रहे हैं? Heat के बारे में पढ़ रहे हैं, right? So here the calorie means heat. And what is meter? Meter means measurement. So calorimetry is basically a experimental technique or process, you can say, technique or process of of measurement of energy change or heat change, I guess, of heat heat change, because heat is again a form of energy. So what is calorimetry? Calorimetry is experimental technique in which we measure the heat change, the change in heat. Okay, And what is calorimeter? This is a process or technique. And calorimeter होता है, this is a device. Calorimeter. Calorimeter is a device. It's a device or instrument which is to device used to measure heat. Measure heat. So this is known as calorimeter. Okay, so basically we can measure energy changes which is associated with the chemical reactions. Okay, chemical reactions means chemical changes. So in a chemical reaction, if there is a change in heat energy or any energy, okay, तो अगर हमें वो energy measure करना है, how much energy is released, okay, means evolved or absorbed. So we will use this calorimeter, or we will use this technique which is known as calorimetry technique. So in your syllabus, there are two types of calorimeter, which we are going to discuss it over here. Warm calorimeter, and the second one is your coffee cup calorimeter. Coffee cup calorimeter. So there are two types of calorimeter: warm calorimeter and the coffee cup calorimeter. So always remember this warm calorimeter. इसमें हम क्या करते हैं? Here the volume becomes constant. Volume यहाँ पे constant होता है. Okay, and we have in the previous class we have learned that if the volume is constant, okay, if the volume is constant, so yeah, you can see over here. Just a second. Yeah, say this. In the isochoric expansion, if the volume is constant, means the change in volume is zero. So here the work done will be zero. And if the work done is zero, then you will find delta U. We will talk about the delta U, the change in internal energy. The change in internal energy will be equals to the heat at constant volume. So the delta U always equals to the QV in isochoric expansion, means when the volume is constant. When the volume is constant. So in this bomb calorimeter, the volume remains constant. And when the volume remains constant, so you know the heat change you will, so heat change आप measure करोगे QV. You will talk about the QV, the heat with at constant volume, at constant volume. So this is the warm calorimeter. Now let's understand this whole setup. The what is warm calorimetry and what is this setup? How this setup works? The working of a warm calorimetry. कैसे work करता है? So first, before working, you should know what is the principle of this warm calorimeter. So principle of this warm calorimeter is heat produced. The heat which is produced is equals to the heat absorbed. Heat absorbed. That's the principle of this warm calorimeter. Okay, now let's understand this whole setup. Now see this large container. You can see two containers, one large container, and in this large container there is another container, this one. So this large container is but the wall of this large container is adiabatic wall. Adiabatic wall. Now what does adiabatic wall means? Adiabatic means no exchange of heat, right? There will be no exchange of heat, means thermal conductivity is banned over here. Thermal conductivity is not allowed, means internal heat जो change होगा, it will not transfer outside. ये बाहर नहीं जाएगा because the wall is adiabatic. The wall is adiabatic. So there will be no transfer of heat outside the wall, outside this container. Okay, so this setup is this is adiabatic wall. Okay, and ऊपर भी होता है properly इसे proper seal किया जाता है इस container. This container is properly sealed. You can see over here, this is properly sealed. Okay, so this is a whole setup. This is the adiabatic wall, and you can see in this inner one, this inner container, this inner container is your bomb. This is known as bomb. Metallic, this is basically a metallic or a steel container होता है ये. This is your steel container. Steel container with known heat capacity. इसकी known होती है heat capacity. So this steel container is known as your bomb. This is your, this container, basically this whole setup, this small container is known as your bomb. Is known as bomb. Now see, you can see over here, this is your oxygen inlet. This is your oxygen inlet. So from here it is connected, this inlet is connected to a oxygen cylinder. वहां पे ऑक्सीजन सिलेंडर से प्रॉपर continuously supply होता है ऑक्सीजन का, right? So from here, from this oxygen inlet, the oxygen has been supplied in this container. Okay, now see what is the difference between the large container and the small container. So this small container is, this is thermal, basically here this is your, this is not a adiabatic wall, this is not a adiabatic wall, this is a conducting wall. This is a conducting wall. Conducting wall. Okay, so it's इस container को internal जो container है इसका जो wall है, this is a conducting wall. Means here the thermal conductivity is allowed. Thermal conductivity is allowed. Okay. Now this is the oxygen inlet. तो यहाँ से oxygen supply होगा. Okay, within the container. This is small container. So here the oxygen is air under pressure. Under pressure. Now see, you can see there are two firing leads over here. These two leads. Now see, this whole setup is sealed. ये proper sealed है. Don't think there is a space. Okay, there is no space. Matter could not enter from here. Okay, all are sealed. Okay, it's proper sealed. Only these two firing leads are there. Okay, and here you will put the sample over there. Sample means, sample here you will take as a any fuel. आप कोई भी fuel लोगे. Suppose you can take the your graphite like carbon. Okay, so carbon, you can put the carbon over here. Now what happens? This is a firing lead. It's just work as a your flinter. Okay, just like your lighter. Lighter जैसे work करता है. You're just in the kitchen. Okay, it just create a sparkling. यहाँ पे sparks create करने के लिए ये use होता है. When you touch these two wires, firing leads, it creates a charge over here. It creates a charge. Due to that, because you know oxygen supports combustion, तो यहाँ पे ignition होता है. यहाँ पे क्या होता है? Because here's a sample which is carbon. Okay, it's in solid form. Now what happens? There is oxygen. When you spark, when you connect these firing leads, what happens? यहाँ पे spark generate होगा. Due to the spark, there will be a combustion. यहाँ पे ignition होगा. There will be a chemical reaction. So carbon, it will react with oxygen and it will form carbon dioxide. Okay, so what happens over here? What happens when this ignite? So यहाँ पे कुछ reactions होंगे, and due to that reaction, the heat is evolved. Heat must be evolved during the reaction. When this reaction happens, when the combustion reaction happens, when this basically any fuel, suppose you just take your carbon. So carbon, when burned, it produces some energy, some heat. So basically heat is evolved during this reaction, which is transferred to the water. यहाँ पे heat release होगा because this wall is not a adiabatic wall. This is a conducting wall. Okay, conducting wall. So when due to the reaction, some heat must be released. When the heat is released, it's being transferred, okay, to the water. This is the water. यहाँ पे water पूरे में fill है. Okay, this whole large container में क्या fill है? Water. So when the heat is evolved during the reaction, it is being transferred to the water, okay, around the bomb. And why this is a stirrer? यहाँ पे stirrer लगा होता है. So stirrer basically it slowly it moves. Okay, stirrer है यहाँ पे, slowly moves करते हैं. And why you put the stirrer? What is the use of the stirrer over here? To mix the water properly. To mix the water properly so that heat will be transferred throughout the water. पूरे water में वो heat transfer हो जाए, so that we just put the stirrer over here. Okay, and the speed of the stirrer should not be very fast. अगर बहुत फास्ट हो गया स्पीड, so due to the mechanical energy इससे भी heat produce होगा, and due to that temperature also rise. So due to that the stirrer should be very slowly stir होना चाहिए, and due to that the heat must be transferred through all of the water which is present in this large container. Okay, so after this, when the heat is evolved and it is being transferred through all the water, okay, all the around this bomb, so the temperature, because heat is evolved and ये transfer हो रहा है पूरे water में, and this thermometer का यहाँ पे क्या काम है? Thermometer here is to monitor the temperature change, to monitor the heat change. So here you place the thermometer is dipped inside the water, and what happens when the heat changes? When the heat changes, because it's properly a you can say it's a adiabatic process, right? Here the heat transfer nahi ho raha hai, heat transfer outside nahi ho raha hai through the, so here there is no loss of heat to the surrounding. Okay, so what happens, this due to this thermometer monitor the changes in heat change measure karta hai, and you will get delta. What is the change in temperature? It will monitor that. And because since the bomb calorimeter is sealed, okay, it's totally packed, so its volume remains constant. Volume is not increasing. Volume is not increasing. So you can check over here. Volume kya ho raha hai? Volume is still the same. Volume of water still the same. It's not changing. Okay, it's not increases or decreases because the whole setup is being sealed. So the bomb calorimeter is sealed, so its volume does not change. So the energy changes which is associated with the reaction, this reaction. Okay, so this reaction are measured at constant volume. Volume should be constant. So you will write QV. Okay, the heat at constant volume. And if you place, what is the formula of delta U? So delta U is equals to Q plus W according to the first law of thermodynamics, right? Now, delta U is equals to Q, and what is W? What is W for the isochoric process? Not W, we can write over here. W basically is what is work done. Work done हमने last class में formula सीखा था, minus P into delta V, the product of external pressure and the change in volume. Okay, so you can just substitute it over here. Plus minus will be minus, so it will be Q minus P delta V. Now this whole setup in this bomb calorimetry, you can say, so the delta V is constant. Okay, the volume is constant, so here the delta V is constant. So if it is 0, ye constant hai, so this whole thing will become 0. So here, when the change in volume is constant, is 0, then the change in internal energy will be equals to the Q. Okay, the change in internal energy is equals to the heat released. Okay, heat which is evolved, and the heat which is evolved is monitored by this thermometer. The change in heat, okay, monitor kiya jata hai. So, and you can write QV. QV is basically the heat at constant volume. Heat at constant volume. And we have, so delta U is equals to QV is equals to CV into delta. So this is the, what is CV over here? CVC, capital C is the specific heat constant at constant volume. Okay, so हमने कल देखा था at the last, you can see this was the formula of heat capacity. Yeah, you can see this. So heat capacity is Q. Q is equals to C delta T. C delta T. So from here you can write down QV is equals to CV into delta. And Q, your heat change, your heat at constant volume is equals to the internal energy change, the change in internal energy. So that's why delta U is equals to QV is equals to CV delta. Okay, so this relationship you will use in the numericals. Okay, so directly questions nahi aate. Basically, it will come in the form of a numerical. So they will give you that in a bomb calorimeter, the internal energy is this, and you have to calculate the specific your heat capacity. Okay, so that's how you will calculate the heat capacity or anything. So these values will be given in your exam, and you have been asked to find any one of them. Okay, so just remember this. So when we talk about the bomb calorimeter, so always remember the volume should be constant. Volume should be constant, and from the bomb calorimeter, we calculate the delta U, the change in internal energy. The change in internal energy. Clear, Sanidhi and Neha?
Yeah, mom.
Yeah, this whole setup, it is clear? Or any question from that?
No, mom.
Okay, now next you can write over here. So after this point, just write down. This. It shows the heat change at constant volume. Constant volume. This bomb calorimeter. And by and no need to write down this point. Just try to understand this. By this equation, you should know this equation, not this equation or this relationship. You can say delta U is equals to QV is equals to CV delta T. So by knowing these values, we can calculate how much heat is released, or absorbed by the sample or system. Okay, and you know very well when the heat is released, the sign convention kya hoga when the heat is released? Negative. And when the heat is absorbed in the case of endothermic and exothermic. Yeah, let's understand this. In the case of endothermic reaction, if the reaction is endothermic, okay, so endo means the heat is gained, energy gain ho raha hai, energy is being absorbed, okay, or gain ho raha hai, absorbed or gain, these two terms you can use. So in the endothermic, अंदर की तरफ क्या हो रहा है? अंदर की तरफ energy, your heat is being increased, heat gain हो रहा है, absorb हो रहा है, तो अंदर का energy क्या हो रहा है आपका? Increase हो रहा है. Okay, so this is an endothermic reaction. If the internal energy or heat is being gained, okay, is increased, so your reaction, though your heat, or you can talk about your QV. Here in the case of QV, it will be positive. Okay, and delta U is also. So for the endothermic reaction means जहाँ पे heat absorb हो रही है. Okay, when the heat is being absorbed, so your QV heat at constant volume will be positive, and the change in internal energy will also be positive. Second case is for the exothermic reaction. Exothermic reaction means heat is evolved, heat is being released from the system to the surrounding. Okay, from the system to the surrounding. System से surrounding में evolve हो रहा है, release हो रहा है. So that's the exothermic reaction. So here you can write down heat is evolved or released, okay, or loose. It is being loose. So in this case, QV will be negative. The sign convention kya hoga? It will be negative, and again the change in internal energy will also be negative. Got my point?
Yes.
Okay. Okay, write it down.
Ma'am, you'll be sending these notes, right?
Yeah, I will. Yeah, but at least write it down.
Yeah.
Some points which I am, yeah, write it down. I will share it. Next is your coffee cup calorie meter. Okay, coffee cup calorie meter. So see, it just look like this. Coffee cup. So coffee cup calorie meter में this is an open type of system. It's not isolated. Yeah, हम bomb calorie meter में क्या दे थे? It's an isolated system. Okay, it's being sealed from the outside surrounding. It's an isolated system. Okay, heat change नहीं हो रहा था from the external surrounding. From the surrounding to the system, heat change नहीं हो रहा था. Okay, but here in the coffee cup calorimeter, we just take the open system, open type of system हम लेते हैं. There is not a isolated, it's not an isolated system, right? तो यहाँ पे कोई सीलिंग नहीं होती, कोई लिड नहीं लगा होता, just an open system. Okay, so here the chances of heat change is more. Heat loss का chances ज्यादा होता है. So coffee cup calorimeter is another type of calorimeter. And here you have to remember coffee cup calorimeter में हम क्या करते हैं? We just, because it's open system, so we just talk about the atmospheric pressure. Okay, so here the atmospheric pressure पे हम बात करते हैं and the pressure remains constant. Pressure remains constant. So basically coffee cup calorimeter is a, in this we measure the heat change at constant pressure. At constant pressure. So how you will write Q and P at constant pressure, QP. So here, when at constant pressure, which type of energy is measured? Which type of energy is measured? We have already discussed that. At constant pressure, if the pressure is constant, तो इस केस में हम क्या निकालते हैं? In the bomb calorimeter, it was isochoric process. The volume was constant. So here we just talk about the delta U, the change in internal energy. So same as that, in coffee cup calorimeter, we will talk about the constant pressure. The pressure remains constant. So here we will measure which change? Enthalpy change. Delta H की बात हम करेंगे. Right? So we will talk about the delta H. We will measure the enthalpy change, not the internal energy change. So see the difference between these two. Okay. If you don't remember, you don't recall. So let's see the notes. I have already discussed it over here. Yeah. See this. Isobaric process. Okay. If the pressure is constant, it means this process is isobaric. The pressure remains constant. So if the pressure remains constant, QP is equals to delta H. Okay, so we will talk about the change in enthalpy. Enthalpy change की बात करेंगे. Okay, now let's understand the whole setup. First, so this is a coffee cup calorimeter. So why we call it as a coffee cup calorimeter? Because in this, we just take the coffee cup, means styrofoam cup लेते हैं. We just take the foamed cup, foamed polystyrene cup. Okay, foam polystyrene cup. Now, why we just take the styrofoam cup? Styrofoam cup क्यों लेते हैं? Foam cup क्यों लेते हैं? Because this will not conduct heat much. This will not conduct heat much. So that's why we just take the styrofoam cup. तो यहाँ पे हीट ज्यादा हीट कंडक्ट नहीं करेगा, तो देयर विल बी नो लॉस ऑफ हीट. ओके, लॉस तो होगा बट नॉट मच लॉस ऑफ हीट. ओके, वेरी स्मॉल लॉस ऑफ हीट होगा. So due to that, there will be a there will be a change. The change will be very precise. Okay, very precise. Not accurate to nahi milega, because here you can see you are using a styrofoam cup, and a styrofoam cup will conduct heat, but not much. Okay, this will not conduct heat much. So that we will take the styrofoam cup. So here again, there will be a loss of heat. Okay, but ज़्यादा heat loss नहीं होगा, so that's why we just take the styrofoam cup. Okay, now next. So and here we just dip the thermometer. Thermometer हम dip कर देते हैं water में. Okay, and continuously the atmospheric pressure has been applied. यहाँ पे atmosphere के पास pressure है, and atmospheric pressure continuously यहाँ पे apply means here the atmospheric pressure remains constant. It's constant, right? Because the thermometer is being dipped inside, right? So heat loss होने से पहले it will monitor the change in heat. It will monitor the change in heat because it has the thermometer is being immersed in the heat in the water. And now, what about the reaction or chemical reaction? So here we just in the water हम क्या रखते हैं यहाँ पे reaction mixture, which is dissolve the reaction mixture reaction mixture in this water. Okay, system is basically dissolved in the water. System को हम dissolve कर देते हैं water में any reaction जिसे जिसका हमें temperature note down करना है. Okay, means the change in heat note down करना है. So we just dissolve this reaction mixture in this water. So when you जैसे ही आप dissolve करते हो water में reaction mixture को, so what happens? Because there will be a reaction, and if the reaction is happening, so either the heat is absorbed or heat is being evolved. दो probability होती है, either the heat will be evolved or the heat is being absorbed. Okay, and वो कैसे पता चलेगा? It will tell the this thermometer. Okay, this thermometer will tell us that how much heat is being evolved and how much heat is being released. Okay, so if the heat is being released हो रहा है तो आपका जो change आएगा it will be negative, and if the heat is being absorbed तो आपका जो change आ रहा है it will be positive change आपको मिलेगा. So once you dissolve the reaction mixture in the water, what happens? There will be a reaction. Okay, there will be a reaction and there will be some heat loss. Okay, either heat will loss or heat will be absorb होगा या तो evolved होगा. So because the thermometer is inside, okay, which is dipped in the reaction mixture, so it will read the heat. It will read the heat change before the loss of heat. Before, because this is an open system, and ये open system है तो heat भी loss होगा easily, right? Because the thermometer is dipped inside. So loss होने से पहले it will monitor the change. It will monitor the heat change. Okay, because it's an open system, so heat is being released in the surrounding. ये surrounding में release भी हो रहा है, यहाँ से loss हो रहा है heat का. So before the heat loss, this thermometer, which is immersed or dipped in the water, it will monitor the change. Once it will monitor the change, you will get to know what is the change. यहाँ पे change क्या आ रहा है? Heat की changes क्या हो रही है? Okay, and because you have here in the coffee cup calorimeter, the temperature is constant. So at constant pressure, you know very well, delta H, the change in enthalpy, is equals to QP. It is equals to QP. And in terms of heat capacity, the QP is equals to CP into delta T. Okay, so delta T कहाँ से आएगा? आपको यहाँ से आएगा. Initial temperature was something and the final temperature after the reaction was something. So आप उसे minus करोगे, you will get the delta T. Okay, and the CP of this container or this water is known. वो known होता है, it will be given in your numerical problem. So you will put the CP over here and you can calculate delta H, and from that relationship. So this relationship को derive करने के लिए we have performed this experiment. Okay, you will perform this experiment in your lab as well. Okay, so once you perform this, so it will be more clear to you. So that's how a step by step methodology you will perform this in your lab. Okay, so for the exothermic reaction, again, it will be same for exothermic reaction. So exothermic मैंने कहा, it means heat is being released or evolved. So here the QP, because we are talking about the QP, so QP is negative, okay, because release हो रहा है, and delta H is negative. Both delta H is also negative. Okay, and enthalpy of the reaction of acid electro delta H, and here R, enthalpy of the reaction. And for endothermic reaction, so QP, the value of QP and delta H both are positive. Both are positive because in this case the energy is being absorbed. Absorbed. Clear, Neha and Sanidhi?
Yes.
Okay. Okay, so these two things is important. Bomb calorimeter. तो बेसिकली न्यूमेरिकल्स में अगर गिवन होगा लाइक इन अ बॉम्ब कैलोरीमीटर, so वहीं पे आपको एक माइंड में ये क्लिक होना चाहिए दैट वी आर टॉकिंग अबाउट द कांस्टेंट वॉल्यूम. It's on constant volume, and this relationship you should know. Delta U, we will measure delta U is equals to QV is equals to CV delta T. Okay, and in bomb calorimeter, because you know what is the relationship between delta U and delta H. Okay, if you know the relationship or any formula in which delta U is equals to delta H plus something, so you can easily calculate the enthalpy change also. Enthalpy change भी आप calculate कर सकते हो. Okay, so these two things you should remember. Now, let's apply this in the numerical. Question. Question is 1 gram of graphite. 1 gram of graphite is burnt in a bomb calorimeter in excess of oxygen at 298 Kelvin and 1 atmospheric pressure according to this equation. Okay, the carbon, it's being carbon plus O2 and आपको CO2 बन रहा है. Okay, just like this. बॉम्ब कैलोरीमीटर में हमने सैंपल क्या डाला था, ग्रेफाइट. ओके, एंड वो इग्नाइट होके कार्बन डाइऑक्साइड रिलीज कर रहा था, सेम एज दैट. So during this reaction, the temperature rises from this 298 Kelvin to 299 Kelvin. Now, if the heat capacity of the bomb calorimeter is 20.7 kilojoule per Kelvin, so what is the enthalpy change? Here they have asked the enthalpy change, not the internal energy change. Okay, from the above reaction at 298 Kelvin and 1 atm atmospheric pressure. Okay, do you want to try this? Just try to solve this. It's very easy. One gram of graphite is burned. Okay, so first you can see the temperature. Initial temperature was 298 Kelvin. And final temperature was 299 Kelvin. So delta T क्या हो जाएगा? Delta T will be T final minus T initial. Okay, so it will be 299 minus 298 Kelvin. So it will be 1 Kelvin. So that delta, the change in temperature is 1 Kelvin. Only 1 Kelvin ka change. Okay. Next. Now the temperature change हमने find कर लिया. Now let's calculate the heat absorbed by the calorimeter. Okay, so because heat which is absorbed by the calorimeter. So this is write down heat Q calorimeter. Calorimeter. Calorimeter ने कितना absorb किया है. So heat you can write down here, heat absorbed by the calorimeter. So if heat is absorbed, it means the heat का convention क्या होगा? It will be positive. The convention of the sign convention will be positive. And what is the formula? So Q calorimeter is Cp into delta T. Because it's a bomb calorimeter, so we will talk about the volume at constant volume. So it's Cv multiplied by delta T. Now Cv value is given. See, The heat capacity of bomb calorimeter is 20.7 kilojoule per Kelvin. Now substitute the value 20.7 kilojoule per Kelvin into your 1 Kelvin. 1 Kelvin. Okay, so Kelvin will cancel it out. This is per Kelvin and this is Kelvin. So this will cancel it out and you will get the value in 20.7 kilojoule. So that's the heat. As a heat absorbed by the calorimeter is 20.7 kilojoule. Heat absorbed हो रहा है, that's why it has a plus sign, positive sign. Now, heat heat released by the reaction. Reaction हो रहा है यहाँ पे, तो there must the heat will be released. यहाँ पे कुछ release हुआ होगा. So let's check it out. Heat released by the reaction. So how much? So it will be Q reaction. Okay, heat released by the reaction is equals to minus of Q calorimeter. Okay, because heat यहाँ पे release हो रहा है. So and the heat according, yeah, see the principle. What I said in the starting, the principle of the bomb calorimetry is heat produced is equals to heat absorbed. Right? Heat produced is equals to the heat absorbed. So heat which is produced by this reaction is always equals to the heat absorbed by this calorie meter. Okay, so here this whole setup is known as calorie meter. यहाँ पे calorie meter क्या है? This whole large one. Okay, ये only not this only one. This bomb is not the calorie meter over here. Okay, whole setup is the calorie meter. इसे हम whole setup को calorie meter कहेंगे. But in this coffee calorimeter, this coffee cup is the calorimeter. Okay, coffee cup is the calorimeter. Okay, so what happens? According to the principle, you know the principle very well, heat produced होगा, which is equals to the heat absorbed. So here we are applying that principle. So the Q of reaction, okay, the reaction का क्या हो रहा है? Release हो रहा है and the calorimetry will absorb. Okay, so because it's being released हो रहा है तो यहाँ पे negative sign. That's why I have put negative sign, right? So this will be equals to minus 20.7 kilo. So that's why heat released by the reaction, and जब release होता है तो there must be negative sign. Okay, release हो रहा है means negative sign should be there. So that's why the Q of reaction, okay, the heat released by the reaction is equals to the heat absorbed by the calorie meter. Okay, so it's the negative minus. Clear, Sanidhi and Neha?
Yeah, ma'am.
Next thing, here I'm writing. Now see, now you have to calculate delta U. You know, delta U per mole. Delta U per mole. Okay. Because जब हम डेल्टा यू की बात करते हैं चेंज, तो वी विल टॉक अबाउट द पर मोल कितने चेंजेस आ रहे हैं. So here you have to find out the number of moles. So number of moles is, what is the formula of number of moles if the mass is given? Sanidhi,
Sorry, ma'am.
what is the formula of number of moles when the mass is given?
What's the formula of
Number of moles.
um
In terms of mass. No? फर्स्ट चैप्टर में हमने पढ़ा था. नेहा, do you know the formula?
Given mass by molar mass.
Yes. Given mass by molar mass. So here, what is the given mass? 1 gram of graphite means the given mass is 1 gram. And what is the molar mass of graphite? Graphite is the allotrope of your carbon. Okay, so carbon का जो mass होता है same as that graphite का भी होगा. तो carbon is 12. The mass of carbon is 12. So 1 upon 12. Given mass upon molar mass. So that's the mole. 1 upon 12 is the mole. And we are calculating the delta U per mole. delta U per mole, change in internal energy per mole कितना हो रहा है, we are finding that. So delta U is equals to, and delta U is equals to, you know very well, for the when the it's for the isochoric process when the volume is constant. So delta U is equals to Q, and here the Q basically Q of the reaction is negative, so that's why you will put negative over here, negative U divided by moles. Okay, so minus 20.7 per mole find कर रहे हैं, and that's the mole हमने ये निकाला 1/12, 1/12. Okay, now 12 को ऊपर ले जाओ, so minus 12 into 20.7. 20.7. So just multiply it. So it will give you minus 2248.4 kilojoule per mole. Minus 248.4 kilojoule per mole. So that's the delta U value. ये delta U की value. Okay, but you have to calculate the delta H value. Now, who will tell me what is the relationship between delta H and delta U? Delta U and delta H. Means you guys are not revising the topic. We have already discussed that. Say this. Delta H is equals to delta U plus delta NGRT. Yeah, so that's the formula. So we have first, you will write down the reaction. The reaction was carbon when it reacts with O2, gaseous form, so it will give you CO. Okay, and how you know very well how to calculate the delta Ng. Number of moles, the change in the number of moles in of gases. So you will find the gases only. आप सिर्फ gases के number of moles find करोगे, not the solid one. So you will not calculate this carbon because the carbon is in solid form. So you will include this as a reactant and this is the product. So delta Ng will be the number of moles of product minus the number of moles of reactant. Okay, and moles हम यहाँ पे क्या लेंगे? The coefficient which is over here, 1. Okay, so 1 minus 1. So here the change in the number of moles is 0. The change क्या है? It's 0, right? Okay. So here the change is 0. So now you can just see this is the relationship between delta H. So delta H is equals to delta U plus delta NGRT. Now this whole thing, this delta Ng is 0. So whole thing becomes 0. ये पूरा क्या होगा? 0. So delta H will always, here in this case, it will be equals to delta U. And you know the value of delta U. So delta U is minus 248.4 kilojoule per mole. So that's the value. Okay, so this type of question can come in your exam from the bomb calorimeter, right? So 1 gram of graphite. So first we have to just calculate the change in temperature. After that, you have to basically just understand the principle of bomb calorimeter. So you should know the heat absorbed will always be equals to the heat evolved. और heat absorb कौन कर रहा है? Calorimeter. And heat evolve कहाँ से हो रहा है? By the reaction. By the reaction. So these two must be equal, okay, in the bomb calorimeter. So first you will calculate the heat absorb, and absorb हो रहा है तो it must be positive value, and heat release हो रहा है तो it must be negative. Okay, and the formula you will use over here. So everything is very, very important. Each and every term you should know what is the formula, what is the relationship, and what is the sign convention is very important. Yeah, इस chapter में आप silly mistake नहीं कर सकते. So sign convention, if it is absorbed, so the sign should be positive, release, then negative. So just remember these terms. Okay, and you should practice more questions based on this question, this topic, warm calorimeter, your coffee cup calorimeter. Okay, so that आप perfect बनोगे and you will not do the silly mistake in your exam. Okay, Neha and Sanidhi,
Yes,
Okay,
ma'am.
ma'am.
is this question clear?
Yes.
Okay, so the next question. Calculate the number of kilojoule of heat which is necessary to raise the temperature of 60 gram of aluminium from 35 degrees Celsius to 55 degrees Celsius. And molar heat capacity of aluminium is given, right? So from here, it's again very easy. First, try to solve by yourself. Any idea how you will solve this question? Okay, let's see. So what is given? What is given in the question? Molar heat capacity. So molar heat capacity आप कैसे लिखते हो? Cm. Molar heat capacity of aluminium. It's given, which is 24 joule per gram. Per gram. So molar हम केस में बात करते हैं. The heat capacity in terms of grams. That's a molar heat capacity. Now it's given. Now the temperature. The yeah. The total number of heat go at temperature of 60 gram. The mass is given. Mass is given and the temperature difference is given, means initially it was 35 degrees Celsius and it will increase to 55 degrees Celsius. So here delta T is basically 20 degrees Celsius. 55 minus 35, so 20 degrees Celsius ka changes. Okay, and this is the, now see, to increase the temperature by 1 Kelvin. Okay, if you increase the temperature by 1 Kelvin for 1 mole of aluminium, 1 mole of aluminium. So we need 24 joule. We need 24 joule. So basically, we have decoded the for definition of molar heat capacity. So what is the definition of molar heat capacity? 1 mole, 1 mole. So the heat capacity per mole. Okay. So per mole or per basically per gram. Molar heat capacity given. Molar heat capacity is given. So we will talk about uh, the gram, the moles. Okay, you can see the definition over here. So what is molar heat capacity? Yeah. So molar heat capacity is basically, it tells about the amount of heat needed to increase the temperature of 1 mole of a substance by 1 degree Celsius. Okay, so its temperature is basically, the unit is joule per Kelvin per mole. Okay, so you can check here, joule per gram. Here the joule per gram, so you can correct it. It should be joule per mole. Joule per mole होना चाहिए because it's a molar heat capacity. Molar heat capacity. If it is a specific heat capacity, then the unit should be joule per gram. Okay, but it's molar heat capacity, so its value should be its unit should be per mole. Okay. So what does this mean? Molar heat capacity means per mole की बात कर रहे हैं हम, right? So to increase the temperature by 1 Kelvin for 1 mole of aluminium, we need 24 joule. We need 24 joule. Now to increase the temperature by 1 Kelvin, if it is 1 Kelvin for 2 mole, अगर यहाँ पे 2 mole है, so we need we need how much? So you will multiply it. You will multiply it by 2, right? So again, 1 mole increase करने के लिए for 1 mole of aluminium, we need to increase the temperature by 1 Kelvin. So this much energy is being uh, needed. Okay, this much energy is being needed. 24 joule energy की requirement है. But if it is to increase the temperature by 1 Kelvin, the temperature is same, but the number of moles यहाँ पे change होंगे 2 moles. So we will multiply it by 2. 2 into 24 joule, right? So it will be 48 joule. Okay, I will try to. This is very basic mathematics में जैसे हम करते थे, right? So this is very basic things. Now to increase to increase the temperature by 2 Kelvin for 1 mole of aluminium. 1 mole of aluminium. Now tell me how much energy you will need. Just read the sentence once again. To increase the temperature by 2 Kelvin. Now the temperature increase हो गया 1 से 2 आ गया, but the number of mole is 1 mole only. Just compare this by first sentence. How much energy is required? Yes. Just the unitary method हम use कर रहे हैं. Just think about it. If you have to increase 1 Kelvin temperature by 1 Kelvin for 1 mole of aluminium, so the energy is 24 joule. Okay, but we have to increase the temperature by 1 Kelvin, but 2 mole of aluminium. So यहाँ पे हम 2 multiply कर रहे हैं. We are just multiplying 24 by 2. So you will get 48 joule. You will require 48 joule. But if the number of mole is same, and if you are increasing 2 Kelvin to increase the temperature by 2 Kelvin, so again you will multiply it by 2. 2 into 24. First sentence से compare करोगे 2 into 24. So again 48 joule is required. 48 joule is required. Now again, if I ask you to increase the temperature by 2 Kelvin for 2 mole of aluminium. 2 mole of aluminium. So how much energy is required? Sanidhi?
Uh, Ma'am, you have to multiply 24 into 4.
Yes, very good. 24 multiplied by 2 into 2 means 4, right? So you will get 2 and this 2 and this 24, right?
96.
Yeah. Okay. So basically मैं क्या समझाने की कोशिश कर रही हूँ? See, now we will yeah, so this to increase, now you will tell me to increase the temperature by what is this? So 20 degrees Celsius is equals to how many Kelvin? 20 degrees Celsius is equals to how many Kelvin? How you will convert this degree Celsius to Kelvin?
Ma'am, Celsius to
Celsius to Kelvin.
do we have to add
Yes.
ma'am, we
Basically,
have
degree
to add in 200
73.15. Yes, 273.5. Okay. So basically Kelvin में because the basic thing मैं समझाने की कोशिश कर रही थी कि if there is some temperature, Okay, so you can also write down 1 Kelvin. यहाँ पे आप 1 Kelvin नहीं लिख के 1 degree Celsius कर दो. It's the same thing. It's the same thing. 1 degree Celsius if you are increasing 1 degree Celsius, right? So you will get the same thing. Now to increase the temperature by 20 degrees Celsius. 20 degrees Celsius आप कर रहे हो तो 20 degrees Celsius for. So number of mole you have to calculate over here. Number of moles. So what is the number of mole? Given mass upon molar mass. So all aluminium ka given mass is 60. And what is the molar mass of aluminium, Saniti? Atomic number is 13, right? So given mass is, molecular mass is 27, right? So 27 of the 60 divided by 27. So this is the basic thing you should know. The number of moles is given mass upon molar mass. The given mass of aluminium is given in the question 60 gram. And the molar mass is 27. So you can calculate the number of moles from here. Number of mole. This is the number of mole of aluminium. Now, how you can calculate it? So the molar heat capacity is given, right? The temperature is given, and this number of moles is given. So the temperature, जितना आपने raise करना है 20 multiplied by the number of moles, 60 upon 27, multiplied by the molar specific here, yeah, molar heat capacity. And its value is given 24. Its value is given 24. Now, just solve it and just tell me the answer. I think it's 24, not 20. 24. Just a second. The 20 is the. Three is the 24. 3 nines are 27. 3 nines are 27. So 8 upon 9. 8 upon 9 multiplied by 6 twos are 1200. 1200. Now 8 upon 9. 8 divided by 9. So it will give you something 0.89 multiplied by 1200. So when you multiply this, you will get 106. 106,8002. Okay, and now just convert this into the kilojoules, 123. So you will get 106.8 kilojoules. That's the final answer. 106.8 kilojoules. Written?
Yeah, ma'am.
Clear? Any doubt in this?
Well, no, ma'am.
Okay, next is your thermochemical equation. Thermochemical equation. Okay, now write down what is thermochemical equation. So thermochemical equation is a balanced chemical equation that gives the information about the heat change during the reaction. During the reaction, how much heat has been evolved or being absorbed. Okay, so that's the thermochemical equation. So write down it's a balanced chemical equation that gives the information about heat change. Heat change during the reaction. During the For example, again we will take the same thing, carbon and mean sometime. Okay, just a graphite plus O2, the combustion of carbon, which produces carbon dioxide gas. Okay, so in this process, the heat is being evolved, it is being released. So if the heat is being released, so it's the delta H, the enthalpy changes minus 393.5 kilojoule per mole. It's given. Okay, so this type of for this type of reaction, the data will be given in your exam. In the numerical, the delta H value will be given. Like this equation, it is the equation and its delta H is this negative. So negative से ही आपको समझ में आ जानी चाहिए कि the heat is being evolved. It is being evolved in this reaction. Okay, so when the combustion of carbon dioxide, the combustion of carbon, okay, when it releases carbon dioxide gas, so the heat is being evolved. It is being evolved, and the change in enthalpy is minus 393.5 kilojoule per mole. Okay, so basically this balanced chemical equation. So always remember, आपको balanced chemical equation लिखना है. In the numericals also, you have to balance the chemical equation. So that balanced chemical equation will give the information about the heat change, how much heat has been evolved or the absorbed by the reaction during the reaction. So you can also write this carbon plus O2. Okay, and the carbon dioxide gas is being formed as a product plus heat release हो रहा है, तो you will write plus 393.5 kilojoule per mole. So this much amount of heat is being released in this chemical reaction. Clear?
Yes.
Next, the meaning of standard enthalpy. Enthalpy of, yeah. So we will take it as a common standard enthalpy of formation, enthalpy of combustion, enthalpy of atomization. For all the standard enthalpy. अगर enthalpy के आगे आप standard लगा देते हो, तो what does this mean? So standard, when it comes with the standard in that, the name is a standard enthalpy. Standard enthalpy of ionization or your atomization or formation of anything. Okay, so it means that the heat will be measured at 1 bar pressure. Standard जब आ गया, तो it means the heat will be measured at 1 bar pressure. Pressure should be 1 bar. And the temperature can be anything. Temperature can be anything, but the substance should be in their standard state. वो standard state में होना चाहिए. For example, if I say H2, if I say H2, तो आपके सबसे पहले mind में क्या होगा? H2 exists in the gaseous form. Okay, so it's a standard state of H2 molecule is gaseous state. If I say O2, again, O2 is again a gaseous phase. It's a standard. Standard क्या होगा? Standard state is the gaseous state. When I say water, H2O, so what is the standard state of water? Neha, what is the standard state of water? Stable state. Liquid? Water? Liquid? Yeah.
Liquid.
Standard. Yeah. So standard state means in which that substance will be stable. It will be stable. So standard state is that. So yeah. So the temperature can be anything. Temperature, if I say standard anything, standard enthalpy of anything. So the Q will be measured at 1 bar pressure, and the temperature can be anything, but all the substance, all the substance should be in their standard state, in their standard state. Yeah. For example, if it is water, so if I say water at 298 Kelvin, so 298 Kelvin means 25 degrees Celsius. If it is 25 degrees Celsius, so 25 degrees Celsius, the water is in liquid form. It is in liquid state. If the temperature, if I decrease the temperature like 270 Kelvin, like -3 degrees Celsius, negative आ गया. So it will be a solid. It will convert into a solid form. Okay, ice बन जाएगा. Now, the third thing is if I say like 400 at 400 Kelvin means if you are increasing the temperature, you are increasing the temperature, so it will become vapor. The water will become vapor. But the most stable or standard form of water is liquid. Okay, so you will take this temperature for the water. अगर आप reaction में कहीं पे भी water है, so you will take this temperature and the liquid form, the standard state you will take as a liquid form when we talk about the standard enthalpy. If the standard enthalpy included in your enthalpy of what before enthalpy is being included, that is a standard. The enthalpy is a standard. So it means that the substance should be in a standard state. Okay, so suppose water है, तो water will be in liquid state. So you will take the temperature, this temperature in the liquid state. Clear?
Yes.
Okay, so first, one by one, there are some standard enthalpy of formation होता है, standard enthalpy of combustion. So we will we will discuss each and everything in details. So write down the first thing, standard enthalpy of formation, of formation. And yeah, what is in जहाँ पे हमने standard लगा दिया, so here you will represent the enthalpy like this is your enthalpy delta H, enthalpy change. And if you are saying it's a standard, so you will put dot sign over here. Okay, so not sign, basically delta. For example, this is a standard enthalpy of formation, so you will represent this delta HF naught. This, so naught means this is your delta standard enthalpy of formation. So if आप delta HF लिखते तो it's the enthalpy of formation. But it is, if it is not over here, so it means it's a standard. Standard means the Q measured, the heat you will measure at 1 bar pressure, and the all substance should be in their standard state. So that's the standard enthalpy of formation. And formation means you will talk about the product over here. We will talk about the standard enthalpy of product over here, and this is also known as standard molar enthalpy. Molar, standard molar enthalpy of formation. Of formation. So the write down delta H, the change in enthalpy when one mole of a substance is formed. Substance is formed from its elements, from its elements in their most stable state. Elements in their most stable state means standard state की बात हो रही है. Most stable state. So that's the stable state. So that's the standard enthalpy of formation or molar enthalpy of formation. Most stable. Okay, so write down what is molar enthalpy of formation or standard enthalpy of formation. So it's the enthalpy change when one mole of a substance is formed from its elements in their most stable state. Okay, let's talk about some examples. For example, like carbon, again, when it burn O2 carbon, standard state क्या होता है? Solid. The carbon का standard state or the most stable state is solid. Oxygen means gas. Okay, and the carbon dioxide. Again, it will form the gas. Now see here in the it's given that delta HF naught value means the standard enthalpy of formation of carbon dioxide is minus 393.5 kilojoule per mole. Kilojoule per mole, right? So it's given in the negative form. Means what does this mean? Yes, Sanidhi. Negative enthalpy means
That means there is
energy is
endotherm.
released.
Yeah, energy is released endotherm.
Yeah, it's endothermic. Okay, so delta HF value is this. So that's how you will show the enthalpy of formation. Enthalpy of formation. Again, another example like N2. N2 है plus N2 H2. Okay, both are in the gaseous phase and they are just forming NH3. So first of all, you have to balance the chemical equation. Okay, always just when you talk about the enthalpy, because thermochemical equation, this is the thermochemical equation. So you have to balance this, always balance the chemical equation. So this is the nitrogen, one nitrogen here, but here the two nitrogen is there. Okay, three hydrogen, two hydrogen. Okay, so what you are supposed to do, 3 upon 2. Okay, 3 upon 2, so इस side भी equal हो गया. Now, for nitrogen, you can two nitrogen, so you can half. Okay, when you multiply it by half, so it becomes, yeah, now it is equal. Now this is balanced chemical equation. So this will tell, this is the thermochemical equation. Okay, now this equation will give the proper information about the heat change during the reaction. Okay, and how you will write down the delta HF naught value means the formation enthalpy of formation HF naught of NH. Okay, there must be some value. इसकी भी कुछ value होगी, but in the exam, in the numerical part, they will give you the value of formation. Okay, कुछ किसी चीज का, for example, they will provide you the formation of this, and they will ask you, for example, when we do something, I will discuss it later. Okay, I will discuss it by the help of a numerical problem over here. Now see, next, one more thing, enthalpy of formation, enthalpy of formation of elements in their most stable state, in their most stable state, most stable state is zero. State, yeah. So enthalpy of formation of elements in the most stable state is always zero. Now the question is why it is zero? Why it is zero? For example, like enthalpy, अगर हम बात करें enthalpy of formation of delta HF naught of N2, N2O2, carbon, S8, your sodium, your Cl2. So each for the enthalpy of formation of all these is always equals to zero. Is always equals to zero. Now the question is why it is zero? Why it is zero? Because using the definition, what is the enthalpy change? Using the definition, we can see that it takes no energy to produce an element from itself. Suppose, what is enthalpy of formation? What is the enthalpy of formation? When 1 mole of a substance is formed from its element in their most stable state. Their most stable state. और यहाँ पे क्या हो रहा है? Enthalpy of formation of these elements, like N2 की बात करें. So here N2 is again its most stable state. Okay, तो N2 से N2 बनने में कितने enthalpy लग रही है? There is no energy. No energy is produced. No energy is produced when N2 element, basically this N2, N2 से N2 form होने में there will be no energy. No energy is produced, right? For example, O2. Suppose it takes no energy to make O2 from itself. From itself. So that's why the enthalpy of formation, because what is the definition? Definition says that enthalpy of formation is when the 1 mole of a substance is formed from its element in their most stable state. Okay, so most stable state क्या होता है N2 का? Again N2 होता है, and N2 से N2 बनने में there is no energy produced, no energy is produced. So that's why when you talk about the elemental form, this N2 form, N2O2 कहीं पे भी आ जाए, N2O2, the formation enthalpy of formation of your N2, your O2. So these are some stable configuration. So these molecule exist in a stable configuration. So that's why their enthalpy of formation is always zero. We will take the enthalpy of formation of these always zero. Clear? Why it is zero?
Ma'am.
Okay. Now let's do one question. First, write down the relationship. After that, first write down the relationship between delta HF naught and delta HR naught. So delta HR naught is the enthalpy, standard enthalpy change of the reaction, of the whole reaction. Okay, and this is the formation. Formation की बात हम कब करते हैं? For the product only. So what is the, so suppose we have a equation, general equation, the reactant is changing into a product. Okay, so reactant क्या हो रहा है यहाँ पे? Destroy हो रहा है. The reactant is being destroyed. Okay, and this product is being formed. This is being formed, right? So what happens over here? जो form हो रहा है, this is being formed. So जो form हो रहा है इसकी हम क्या बात करेंगे? Delta HF naught. The formation, the delta, the enthalpy of formation of product. Okay, but it is being destroyed. तो इसकी हम बात नहीं करेंगे, like delta H, the formation की बात नहीं करेंगे. So here the formation will be negative. It is just a opposite of formation. It is just a opposite of formation. So can we write minus delta HF naught of reactant? Yeah, so it is just opposite of the formation. So we can write minus delta HF naught of the reactant. Now overall, the change in standard enthalpy of the reaction will be delta HF naught of products minus delta HF naught of the reactant. So here you can derive a formula. So summation, okay. So product एक से ज्यादा भी हो सकता है. So in that case you have to add up the enthalpy change, enthalpy formation. So the summation of delta HF naught of product minus this. So this is the important formula you should remember. This is the important formula. Now, based on this formula, I have a question over here. Question is, write down the question. The conversion of 1 mole, 1 mole of benzene, 1 mole of benzene gives carbon dioxide and water, H2O, with 3267 kilojoule of heat at 298 Kelvin and 1 bar. So we have to calculate the standard enthalpy of formation of benzene. If delta HF naught of carbon dioxide is minus 393.5 kilojoule per mole, and the delta HF naught of water is minus 286 kilojoule per mole. Kilojoule per mole. Okay, so first let's understand the question. What is given in the question and what you have to calculate. So the conversion of 1 mole of benzene. Conversion of 1 mole of benzene. So first you have to write on the balanced chemical reaction. So C6, benzene is C6H6 plus O2. So combust कर रहे हो C6H6 को, so you will get carbon dioxide plus water. Just balance this equation. 6, 3 over here and here 15. Now it's balanced. Now, the conversion of 1 mole of benzene gives carbon dioxide and water with 3267 kilojoule of heat at 298 Kelvin and 1 bar pressure. 1 bar pressure. And you have to calculate the delta HF naught of benzene. Okay, so we have a formula. You can see this. We have a formula. We have to calculate the delta HF naught value. Delta HF naught value, right? This one. This is the reactant. This is the reactant. So we have a formula delta HF. Yeah. So suppose इसे इसका हमने calculate करना है. So let's take the delta HF value as a x. Let's take it as a delta HF naught is equals to x for this, and it's given. See, what is the delta HF value of O2? Who will tell me? Neha or Sanidhi? O2, what is the value of standard enthalpy of formation of O2? Neha, Sanidhi,
Ma'am,
I told you.
I
Yeah,
minus
0.
2.
Why
Huh?
minus 2? It's 0.
Yes,
See,
yes.
the enthalpy of formation of elements in their most stable state is 0. Okay, so O2 अपने most stable state में है, so its enthalpy will be 0. You will take it as a 0. Okay, so that's why I have written some examples over here. When you see this, so you उस time आपके mind में आ जाएगा, yeah, it's 0. The enthalpy of formation of this is 0, right? So you will take it as a 0. And carbon dioxide, it's given minus 393.5, and water, it's again given 2. Okay, now we know the formula delta H naught R, okay, of the reaction. This is for the whole reaction is delta HF naught of product minus delta HF naught of react. Now this is the product. Okay, you have to add up these two, and this is the react.